Now, draw the projections of a point capital A lying 30 mm above HP and in first quadrant. If its shortest distance from the line of intersection of HP and VP is 50 mm, also find the inclination and also find the distance of the point from VP. So here he says it is in the first quadrant, so we have taken the first quadrant in 3 dimension, wherein we have the vertical plane, horizontal plane and the right profile plane. He says it is 30 mm above HP. So when you look from the front view, we can see the distance 30 mm above HP. So since we are looking from the front view, the image is projected on the vertical plane, so that you are going to get the distance above HP by 30 mm. And is in the first quadrant, so obviously the point is in first quadrant. If its shortest distance from the line of intersection of HP and VP is 50 mm. So which is the started distance from the intersection of HP? So this is the horizontal plane, the intersection, and this is the vertical plane. Okay. So from the line of intersection of HP and VP is this line, which is the shortest, which is the distance of the line of intersection of HP and VP. So this line, its shortest distance is from here to this point. So we know above HP and we know this distance, but what we need to find out is we need to find out this distance which is in front of VP. So when you look from the side view, we can see the distance of the shortest distance which can be projected onto the profile plane, which is on RPP, wherein we can see this distance which is the shortest distance. So here he has given this distance as 50 mm, and when you look from the side view, we can see the distance above HP. So this distance is seen, so naturally we will be able to find out what is the distance between these two, or the distance between these two. So this is the distance between these two can be found out in the profile plane. So here this is how we can be analyzed. So the distance with respect to the profile plane, he has not given any distance, so we can take whatever the distance we want from the profile plane. So when you look from the front view, the distance above HP is seen, and also the distance with respect to the profile plane, which is any distance, we can be able to see in the vertical plane. So this is how we can be, it can be analyzed in 3 dimension, and in the step 2 we have rotated the horizontal plane downwards by 90 degrees and the right profile plane to the right side by 90 degree. This is as shown, and accordingly the images on the respective planes are also being rotated. So here, so when you look from the front view, the distance of any distance with respect to the profile plane and also the distance above HP which can be seen. So you consider from this line, you can take whatever the distance you want and then draw a horizontal vertical projector, which is a thin line. Then the distance above HP is seen in the vertical plane, so you can take the distance above HP which has been given as 30 mm. So this is the distance which can be seen in the above HP. When it is projected onto the vertical plane, you are going to get the distance here, which is 30 mm. So from this line, you measure the distance of 30 mm and mark this point. Then when you look from the side view, we can see the distance above HP and also the distance in front of VP, but also the distance with respect to the shortest distance with respect to HP and VP, which is 50 mm. And also front view and the side view both will going to lie on the same line. So since we know the front view and the side view will going to lie on the same plane, same line, so draw a horizontal projector from A dash to the profile view directly. And so we know the distance above HP, but we don't know what is the distance in front of VP, but instead we know the shortest distance from the intersection of HP and VP. So that is here, this is the line which will going to be the intersection of HP and VP. So from this point, you take the shortest distance, which will be go to 50 mm. From this, by using the compass, you cut an arc on the horizontal projector from the front view, where it will going to cut the arc will going to be the A double dash. So now we know this is the shortest distance. Once you know the shortest distance, so you know this is the distance in front of VP. So you draw a vertical projector from here, which is above HP, and then this horizontal distance has to be, this is the in front of VP, so this distance has to be transferred into the vertical distance. So by drawing an angle of 45 degree with respect to the horizontal, we can transform this horizontal distance into this vertical distance and draw a projector here, and also you draw a vertical projector from here, so that it will going to intersect at this point where it will be, since the image is on top view, that is on HP, so we are going to get the top view where A will be equal to the in front of VP. So this L has to be determined by using the scale. We measure the length from here to here, that will be the distance of the point from VP. Since it is in first quadrant, the point is in front of VP by the distance which we found out. It will go to be point by using the scale. So this is how we can be analyzed in 3 dimensions, and also the planes which have been rotated. Now we will going to do the same problem in the sketchbook. So here first you draw the XY line and X1 Y1 line and mark VP and HP and the right profile plane. As it is in the first quadrant, VP will be above XY line, HP will be below XY line, and RPP will be adjacent to VP. Then the distance with respect to the profile plane is not given, so you can take whatever the distance whatever the distance you want, you can take. So from here you draw a vertical projector, and then the distance above HP is seen in VP. So from here you measure the distance of 30 mm and you mark that point, which is going to be the A dash. Then draw a horizontal projector from A dash to the profile view. Then the shortest distance from both HP and VP, intersection of HP and VP, can be seen in the profile view. So from this as center, take the radius of the shortest distance, which will be equal to 50, by using the compass. Cut an arc on the horizontal projector drawn from A dash, because both A dash and A double dash will be on the same line. So once you get this point, you will going to get this point as A double dash. Then draw a 45 degree line adjacent to HP, and then draw a vertical projector from A double dash onto 45 degree line, wherein the distance in front of VP, which is this distance, is been transformed into the vertical distance. Here once you draw this 45 degree line, so the distance which is in front of VP, which was here, when it is drawn here, so this distance has been transformed into the vertical distance here. Then you draw a horizontal projector from here to the top view, where it will going to intersect the vertical projector drawn from the front view. So the point where it intersects will going to be the top view, which is equal to A. So here, since we need to determine the distance in front of VP, so from here to here you measure the distance and keep it as L is equal to question mark. That is the one which we need to find out. By using the scale, you measure the distance from here to here, where L is equal to 40 mm. Even in computer it will be 40.00, and L is equal to 40 mm when you are doing it in manually. So this will going to be the final solution, and show the directions of projection. So from A dash to A double dash, you draw a horizontal projector from A dash, and then from A double dash draw a vertical projector to the 45 degree line, and from 45 degree line draw a horizontal projector to the top view, and where it will going to intersect, you are going to get this point A. And here show the dimension of 30 mm in the front view, which is distance above HP, and this distance will be the shortest distance. From this here you measure R50, which will going to be the radius of 50, which will going to be the shortest distance. So this will going to be the final solution for the shortest distance in first quadrant. Thank you.